Next topic will be on correlation. So this one you can refer back to your notes, your module. Okay, 5.6 correlation. So correlation atau correlation analysis, so perkali analisis korelasi lah ya. Correlation attempts to measure the strength, okay, kekuatan dia, and also the direction, arah dia, okay, of a relationship between two variables, okay, by means of a single number called as correlation coefficient, perkali korelasi. Okay. Particularly, a linear correlation coefficient is a measure of the strength and direction of a linear relationship between two variables. Okay. So kita pakai symbol in here is R. You denote sample data. So R is known as Pearson product moment correlation coefficient. Okay, perkali korelasi Pearson. Pearson product moment correlation coefficient. Okay, there are several types of correlation coefficient. Okay, there are, okay, ini Pearson product moment correlation coefficient biasanya normally used for regression. Okay, they also have Kendall-Tau rank correlation and also Spearman product Spearman correlation coefficient. Okay, for parametric test, ini kita punya parametric so normally we use Pearson product moment correlation coefficient. Okay, kalau macam non-parametric categorical data, kita akan pakai Spearman correlation coefficient. Okay. So the formula is given as XSY, you already divide by square root SXX times SYY. So SSX, SYY. So you have SSY divided by square root SSX, SYY. Okay, so that means we have three values that we already computed from the testing linearity. So in order for you to find your correlation, so just compute SXY divided by square root SSX, SYY. So it can also be computed using your calculator. Okay, in your calculator, after you get A for alpha, B for beta, there is the value R, symbol R in your calculator. So that is your correlation coefficient. Okay, boleh directly from your calculator pun boleh dapat perkali korelasi. Okay, or you can use formula to solve that one. Okay, R should be between -1 and 1. Dia tak boleh lebih, dia tak boleh 1.5, tak boleh. Okay, between -1 and 1. If your R is close to 1, ketika R, it implies that there is a strong positive linear relationship between X and Y. But if your is equals to 1, so that means perfect positive linear. Okay, perfect relationship maksudnya if you plot, you have a straight line relationship lah, straight line linear relationship. On the other hand, if R is close to -1, so strong negative linear relationship. So for example, let's say you have, okay, 0.8 and above lah, okay. So we can conclude that it's strong positive relationship. You have R is positive, we have a strong negative linear relationship. Okay. When you have your R is close to 0, katakan get R equals 0.3. So either from positive or negative direction, it implies there is a weak relationship. Weak kalau no linear relationship, yang memang menghampiri nilai 0 lah. So kalau R dia menghampiri nilai 0, so there is no linear relationship between X and Y variable. Okay. Again, for example, let's say saya compute lah R equal to 0.5 ataupun R 0.6 Okay, I can conclude that positive moderate linear relationship. Okay, bawah less than 0.5, you can say that one a weak linear relationship. Either positive, kalau R dia positif, positif lah. Kalau R dia negatif, negatif. Okay, kalau R menghampiri nilai 0, close to 0, that means there is no linear relationship. Contohnya bentuk kuadratik, bentuk polinomial. So that will be no linear relationship. Okay. So that one nanti kita go back, kita compute directly teruslah daripada dengan menggunakan exercise yang lain, soalan ini. Okay. So now you go to 5.7. So this one is how you want to use ANOVA approach in order to solve dia punya linearity, testing dia punya slope tadi. Okay. Testing the slope, you have two choice. Either you have t-test or you can use ANOVA approach. Okay. So this is the formula where we have ANOVA approach. Okay. The formula is given as summation yi minus y bar square. Okay. That is your sum square of total or total correct. So ini kamu revise balik on ANOVA that you already learned in chapter 4. Okay. The same thing, but this one ANOVA for regression. That one ANOVA for testing more than 2 population. Okay. Summation yi minus y bar square is your sum square total. Total corrected sum of square. Okay. We split into 2 variability. First, sum of square SSR is sum of square regression. Okay, regression sum of square. We measures that the amount by the regression line. So itu masuk dia sum square regression. Amount variability in y accounted by the regression line. Yeah. So the last one should be sum square error. Okay, sum square error is just summation yi minus y bar square. Okay, summation yi minus y bar square. So if we refer back to here, okay, something wrong with module, SST. So SST is just sum square total. Sum square total your S actually. Okay, that means kita dah ada value SYY. Okay, SSR you can compute as X. So that is your SSR. Okay, beta head times SSY. Sum square total SYY, sum square regression is just beta head times SSY. So last, you want to compute your sum square error. So sum square total minus beta head SY ataupun sum square total minus your sum square regression. Okay, so you minus SNR. Okay, sum square regression. So that is your sum square error, which means the residual variation left unexplained by the regression line. Okay, the residual variation left unexplained by the regression line. Okay, that is your sum square error. Okay, kita ada sum square total, sum square regression, sum square error. Okay, if you have any question, you can ask me on your microphone sebab saya tak boleh nak buka chat on the same time. Okay, sum square total, sum square regression, and then sum square error. So next, after you already compute these 3 values, you put in the table of your ANOVA. Okay, table sama dengan ANOVA tadi, ANOVA on previous chapter. So analysis of variance. Okay, source of variation. Okay, second column sum of square, degrees of freedom, mean square, and then your F. Okay, source of variation, punca variasi. So you will have regression, error, total. Okay, regression, your sum square regression, beta head SSY. Error, so that means SST minus beta head SSY, total SST, which is your S. Here is your S. Okay, degree of freedom for regression is 1. Okay, and then you have error is n minus 2, your total is n minus 1. So that means you have to memorize. Okay, the first one, degree of freedom for regression is 1. Okay, sebab kita ada beta 1 je. Okay, you want to test. And then error dia n minus 2. Okay, total n minus 1. And then the same thing, mean square regression. Mean square regression is just mean square regression, your which is 1 lah. So you got 2. Okay, you get mean square error. And last, you compute your F, which is mean square regression over mean square error. Okay, then you compare. Okay, bila kita buat ANOVA approach, okay, analysis of variance, we only reject alpha, not alpha divided by 2. Okay, F alpha, fixed 1, first degree of freedom, second degree of freedom is n minus 2. Okay, tapi kita testing linearity betul lah, alternative beta Okay. But when you conduct your analysis of variance, so reject H naught when F test greater than F alpha, degree of freedom 1 and -2. So macam juga dalam chapter 4. You only consider alpha, not alpha divided by 2. Okay, reject H naught when you have your F test greater than F alpha, degree of freedom for some square regression, and second one is for degree of freedom for errors. Okay. So that is your analysis of variance. Okay. Yeah. So kita nak test, bila kita nak test linearity, so you have two choice. Either you want to use ANOVA approach or you can use t-test. Okay. So that is the first part that you need to understand. So the same thing. So you have sum square total, sum square regression plus sum square error. Okay. Sum square total is just SYY, total corrected sum of square. SSR, sum square regression, amount of variability in yi accounted for the regression line. The same formula, beta head SSY. So because span and then just use this one, beta head SSY. And last, you compute your sum square error. Measure the residual variation left unexplained by the regression line. Okay, and then kita dah ada 3 tadi, kita letak dalam analysis of variance table. Okay, you compute mean square regression, mean square error, and last the F calculated value. So reject when you have your F test greater than F alpha, degree of freedom 1, second, and -2. Okay, ini semua fix, dia tak berubah. Fix. Macam juga dalam ANOVA kamu. Okay, kalau ANOVA treatment K minus 1, N minus K, last N minus 1. Okay, reject when you have your F test greater than F alpha, K minus 1, N minus K. This one for regression. First degree of freedom 1, second, and -2. Okay. So again, analyze to the t-test. How? Okay. So if you compute your t-test is the formula given beta head over square root variance beta head over variance beta head tu maksudnya adalah sigma square head divided by SSX, which is your sigma square head tu adalah mean square error sebenarnya. Sigma square head. Kalau ditanya what is the estimated value for mean square error, you can find your sigma square head tu. Okay. So t-test, kalau kita squarekan dia punya value t-test ni, kamu akan dapat sama dengan value f-test. Kalau t-test square, okay, value of t-test ni kita kuasa duakan, kita akan dapat sama value dengan f-test. Okay. So this one, t-test ni sama dengan beta head SSY, which is your mean square regression over mean square error. So t-test is more flexible compared to ANOVA. Okay, t-test is more flexible in which it will allow testing against one-sided alternative hypothesis. What f-test? F-test maksudnya kita guna ANOVA approach is restrictive test. Maksudnya di sini, bila kita nak test linearity, okay, bila saya mention test linearity, maksudnya null kamu beta equals to 0, alternative beta unequals to 0, you can have two choice. Either you want to use F-test, ANOVA approach, or T-test. But if you want to test whether this one have positive linear or negative linear, which is one-sided test, you need to use only T-test. Dia tak boleh pakai F-test. F-test is only for linearity. For two-sided saja. Okay, kalau two-sided, you can use either F-test ataupun T-test. But T-test, dia lebih fleksibel, dia can handle two-sided and also one-sided test. Itu perbezaan dia. Okay. Okay, kalau let's say the question stated that test linearity using ANOVA approach. So that means you must write using ANOVA approach. Mark is not given when you conduct a T-test. Okay. Kalau let's say dia tak cakap test the linearity and alpha equals to 0.05. So your choice, either you want to use T-test or F-test ANOVA approach. Okay, mana-mana satu. Okay. Ada apa-apa soalan ke? Tak, saya ada okay, apa? Hafiz tanya apa tadi? Ada soalan ke Hafiz?
Sekejap. Saya nak tanya yang kalau tadi saya nak tanya kalau macam nilai S SS dengan SIY tu,
Aha.
kalau kita dah dapat kira melalui kalkulator, so kita kena tunjukkan jalan kerja dekat atas paper tak?
Maksudnya cara kamu nak kira SYY dengan SSY tu.
Kena tunjukkan tak? Sebab ada allocate markah ke untuk pengiraan atas kertas tu?
Okay. Biasanya kita tunjukkan lah, tapi kadang-kadang markah dia untuk SYY, SSY tu satu markah lah untuk jawapan akhir kamu. Tapi kadang-kadang
Ah,
it's better kamu untuk tulis supaya kita boleh detect kalau let's say salah tu salah kat mana.
oh,
Ha,
so kena tulis lah.
better tulis lah, bagi saya better tulis lah.
Okey, terima
Sebab
kasih
kalau
Doktor.
macam kalau macam summation y square xi square tu directly from your calculator, okay lah. Tapi bila kamu nak tulis macam formula SYY kan summation yi square minus tu kan. So better
Nah,
tulis formula tu and then substitute.
oh, okey, faham.
Sebab kalau tidak takut kamu tersalah masuk je instead of given directly from your daripada yang kamu compute tu. Okay?
Okey, baik Doktor. Terima kasih.
So kita try the last one. Ini bukan exercise 11 nitrate, ini extra exercise which is not in your module. Okay. Again, you use your calculator, clearkan your punya data in your calculator. Okay, kita ada X, kita ada Y variable. Okay, X kat bawah The gram of solid removed from a material Y is thought to be related to the drying time. Maksudnya X kamu adalah drying time Y kamu dia punya amount of gram tadi. Okay. So fit a simple linear regression and then test for significance of regression at alpha 0.05. Okay, write down the hypothesis, maksudnya null dengan alternatif. Solve using ANOVA. Okay, lepas tu estimate, maksudnya nak estimate Y bila X kita 4.25. And last, compute the Pearson correlation coefficient and interpret. Okay, compute the Pearson correlation coefficient, you can directly from your calculator pun boleh. Okay, okay, now kamu try masukkan data dalam calculator. Okay, clearkan dulu, masukkan data dalam calculator. Okay, bagi dia punya tu value summation y square semua tu. Okay, from the calculator you can find your alpha head, beta head and also R. Dapat tu? Okay, so you get your alpha head. Okay. Okay, so okay, Syazwani okay. So you get your alpha head is minus 0.1158. Your beta head is 1.1661. Okay. Fatihah, yang respon okay. Okay. And then your punya summation x square 201.25. Summation x 42.5. Okay, summation y square 272.16. Summation y 48.4. Okay, and then summation xy 229.75. Okay, correct. Okay, now you compute your SYY and also SXY, SSX. Okay. Okay, so part A, you already have your fitted simple linear regression. So alpha head negative 0.1158 plus 1.1661x. So untuk part C tu kita kira dulu estimate of the mean. So y head So just replace x is 4.25. So you will get 4.8401. So that is your estimated mean. Okay, last, compute the Pearson correlation coefficient, interpret the value. So R you have here is 0.8602. Okay, so since you have a positive slope, okay, you have positive slope, beta is positive, which is 1.1661. So your R must also be positive. So R is 0.8602. So we conclude we have a strong positive linear 0.86. Okay. So kalau kita dah conclude we have a strong positive linear relationship between x and y. So in kita nak nak testing for linearity tu, you must have the test must be significant. That means you must reject. Dia patutnya consistent lah dengan jawapan dekat B tu. Maksudnya kita kena reject lah kita punya null hypothesis. Okay, now you test for significance of regression using ANOVA. Okay, so find your SYY and so on lah.